Hello and a warm welcome back to my little YouTube channel. Today we're having a look at Q equals mc delta T and a couple of ways that they can challenge you with this style of question. Number one, what is the enthalpy of combustion of ethanol if the temperature of 200 cm cubed of H2O rises by 12.5 degrees C? They always give you the specific heat capacity of water in the question, 4.18 joules per Kelvin per mole. And then joules per gram per Kelvin we have here. We want the answer in kilojoules per mole. So we have to do something with the sum to make the answer in kilojoules per mole. We all know that it's mc delta T over N. N is moles, M is mass in grams, C is the 4.18. And then T, sometimes they ask you or challenge you or try to lead you down the path of putting it into Kelvin. Of course, this is nonsense. It does not need to be in Kelvin because it's delta T, it's change in temperature. It doesn't matter if it's degrees C or if it's Kelvin. It's the same gradation or the same difference. So it doesn't matter. Don't make them trick you into putting that into Kelvin. Do we need to divide by 1,000? Why do we need to divide by 1,000? Is there something with that kilojoules required in the question? Perhaps. Yes, there is something required, because sometimes they ask in joules. You don't need to change because the specific heat capacity is already in joules, but we have to put the answer into kilojoules per mole, so we have to divide by 1,000. So the only things they can do is change the temperature into Kelvin, which you don't do. Moles is mass over mister. Sometimes they put moles mister over mass. Don't let them do that to you. And then just check the units that are wanted for the answer. In this case, it was by 10 to the minus 3, or divided by 1,000. There's not much else they can trick you with on that style of question. 961 kilojoules per mole. The second style of question, they like to ask the graphical questions. They can ask these in paper 1, paper 2, or indeed now we have paper 3 back. I'm sure this will be the same in the new syllabus, but I think there are only 2 papers in there. We have time on the x-axis, and I'm sure you have predicted correctly that we have temperature on the y-axis. The units at the moment are seconds on x and degrees C on y, and we're going to get hopefully the characteristic curve, which you will have seen before, and perhaps you've even done the experiment where you take a polystyrene cup, a thermometer into the polystyrene cup, you allow the temperature to equilibrate, which is the plateau at the bottom. The temperature rises and then steadily falls. If you've ever done this experiment, it only ever looks like that in a textbook. It takes forever to fall because it's an insulated polystyrene cup. In this question, y is a point on the curve which is highlighted, and there will probably be a question shortly about what is y. That's obviously a very, very straight line from Mr. M for Chem, and that is extrapolated to the y-axis to around 81 degrees C. So what can they ask you to do? Well, clearly they can ask you to measure delta T. Where could you measure delta T? mc delta T is Q over N. N is moles. You can work out delta H, which in this case could be enthalpy of neutralization, could be enthalpy of combustion. It's not clear from the temperature yet. It's asking what is point Y. The answer was, and you get many different responses on this, very intelligent, creative responses. The mark scheme was just the highest temperature. That was the highest temperature that was reached. Perhaps a more physical chemistry appropriate response would be when the rate of heat production is the rate of the heat loss. But I'd be quite happy if it said maximum temperature reached, 1 mark. Easy money, easy money. What else could they ask? Well, let's have a look. Yes, here we go. What's the maximum temperature reached? What's the maximum temperature reached? Okay, so that's from the extrapolated part here. Why do we extrapolate? That will probably be the next part of this question, which is all they can really ask on this style of question. There's normally a tolerance on the responses. I've made that 81. As you can see, I freehand drew this. So around 81 degrees C will be the maximum temperature. And by that we mean the delta T, which we put into mc delta T. Okay, because point Y point Y does not take into account? Well, what does it assume, or what does point Y not take into account? Do you have any ideas? Well, we'd only reached the maximum t, which was 81, if there was no lag, there was no delay, if the reaction was instantaneous. Very good. If the reaction was instantaneous, or there was no accounting for the specific heat capacity of the water or the container. Okay, hope that was useful. Comment, like, subscribe. Thank you very much. Have a great day. Bye-bye.